So you can hear me now. Okay, so yeah, I had to add it. I did this video last night, believe it or not. I didn't do it live, and I chose the wrong audio device because I'm kind of experimenting with Streamlabs, and I had an extra monitor, and it was throwing that off there. So good. So I will start over. Awesome, guys. So here goes again, and I'll trim this off on the live one. So the story is, in the last week, I've actually had two unique machines come up with PIC errors. And it's quite unusual because I've never had a PIC error. I had the Pickit kit. For a while, I thought it programmed Eeproms for me, and it didn't. It does on L3s and a couple S9s, but it doesn't on the 17 series boards. So I thought I might do a video on this because I went through it again. I kind of taught myself how to deal with this. So I captured the one error on the one machine, and it's being displayed here. And just let me get that window back with the error message so I can point at it. Where are you? Ha! Let me see, it's right there. Okay, now I can do it. So live stuff is so great, guys. So anyway, I got this error PIC lost. And just one thing of note about this is this was upon restart. So I had restarted the machine just to catch what was wrong with it because the log, it had been running for a long time. And so I rebooted and I caught this. And the one thing to notice about this, of course, is the error of the error log. So it identifies there's something wrong with the PIC. And then secondly, it looks at the PIC on each chain. And so this PIC had a version of B9, and this PIC had a version of FF. Now in hex that's -1, which usually denotes if you're programming it in an error. And indeed that's the error. And so it's like, great. I've lost a PIC chip. It's highly unusual for me in all the fixing I've done on the 17 series to lose a PIC. Now I've talked to a couple of people recently that's all they do is restore PICs and get their boards working. That was on an S17 Plus, I believe. I kind of think there was custom firmware on there and they had to restore it to get it to work. But mine doesn't have custom firmware. It's a stock Antminer software. I'm using Brains or something like that. So when you see this, it doesn't necessarily mean that your PIC chip is bad. It means that it can't communicate to your PIC chip. So this one is still a mystery, I'll be honest. I went out, tried rebooting a couple times, got the same error, went out, unplugged it, maybe sat for 90 seconds, plugged it back in, haven't had an issue since. So it's a mystery. Well, tonight and yesterday, I started having another problem with another PIC chip on a different miner, and this thing would just drop off. It would just lose power, and it's like, oh great, not a second one. It gave me a different type of error. It basically said lost heartbeat. So you may look in the error log and it say we lost the heartbeat for the PIC chip. Evidently the PIC chip sends out a heartbeat saying I'm okay. And that went down. Well, that's not a mystery. I got the miner out of its enclosure today, pulled it out, took it apart, and the data cable was loose. So, but still I wanted to do this video for the first time, but it's just kind of funny I'm running into these. And somebody I had a discussion with today on Discord, we were talking about this, and I wish I had that video ready yesterday for him, but I didn't because the audio was bad and it didn't capture on my screen. So anyway, so tonight I'm going to go through just some discussions. I actually think this error was not a PIC chip error on the first machine. I rebooted and the PIC chip was fine. So you tell me if the flash is good on the PIC chip, it's good and it was able to read it. If the flash is bad, it's not like it's going to come back after I reboot it. It's just going to stay bad. So in both my cases, I still contend that I don't have to refresh the PIC chip program. Now, for those of you guys who don't know what a PIC chip is, a PIC chip is just like its own microprocessor, memory, registers, everything. It's like a built-in computer and a chip that you can use some development tools to program some instructions. And it is the main interface between the controller board and that software and talking to the hashboard. So probably what happens is the controller board talks to the software on the PIC chip, tells it what to do, and the PIC chip handles it on the board. And that way there is some abstraction between the boards and the controller. There's probably, my bet is there's an interface that's probably pretty standard between them, and the PICs are the low-level hardware to take care of the card, the duty on the cards that are real specific. That's kind of my model. Not 100% sure about that, but that's probably how I'd program it if I or build it, if that's how I did it. So we're going to talk about this. So don't always assume that you have to reflash your PIC. I would go look at it. So tonight I was going to pull that card, but it just turns out the stupid data cable was loose. But I'll show you in the microscope. I think you ought to pull the board, look at the PIC, pay particularly attention to the data cable, make sure it's in, look for any bent pegs. Somebody's not communicating with the PIC, that's why. Lost heartbeat, which was my other problem. And I started getting some temperature sensor errors and some no power to it, and that was obviously because of the data cable, but that tells me that low power can also affect the PIC chip. So like I said, I just haven't seen a lot of these go bad. You guys can tell me if you have in chat. It's just my experience with these boards that they don't go bad. So with that said, let's just take a tour of the hashboard and see where this stuff is. Then I'll show you how to set all this stuff and do it. So let me see. I got to move this and turn him off, and I should have my overhead here. Okay. So what I bought the other day was a Pickit 3. They're not that expensive. You can get it on Amazon, Alibaba, all sorts of stuff, all sorts of places. They're not expensive. I think there's a Pickit 2, a Pickit 1, and a Pickit 4. And there's probably even more things than Pickit, but this was a well-known brand. I wanted to buy it. It comes with this funny data cable that's just really, there's nothing special about this data cable. It's just pegs, and it has some colors on the wire. And it plugs in the back, and I'm just going to plug this in the back. And one thing to notice on this tool is this arrow right here. This arrow will become important when we go talk to the board. This arrow means it's probably the power supply, but it is unique. It's identifying, and I try to put the red wire on the arrow so I know what to do with the red wire on the other end of the chip when I put it on the board. The other side of this is just a USB card. I believe they talk about having a backup battery in here. There is a power button, which is kind of bizarre. But when I plug it in a USB port, it comes up. There probably is a difference. So the question is there a difference between PIC 1 to 4? I think there is. I think the newer ones support more chips. So when they had the PIC 1 out, they only had so many chips to support, and then people come out with more chips. So they keep improving it. Let's put it that way. So I guess if you want to be safe, get the Pickit 4. I know for T17s, the Pickit 3 PIC chip is supported. So good question. Thank you. All right, so I'm going to go ahead and show you where this stuff is. So we're going to use this in a second. I'm going to place it aside. Now, where on this board do you plug this stuff in? Let me see, which way is this for you? Okay. So you have the board here, and if you notice, down by the plugs, and it's kind of blurry. Maybe I can hold this up to the camera and it'll behave itself. Light. Okay. So on a T17 board, there's these 5 holes, 6 holes. It's jumper, I can't quite read it, it's jumper 8. So these holes indicate that that's for the PIC programmer. These aren't test holes like these over here that you probably can't see. Those are the test port holes over there. These are actually, they talk directly to, on the other side of the board, and let me get the glare off if I can, the PIC chip, okay? So this is the PIC chip, and we're going to look at it in the microscope in a second. But the PIC chip for this, it's got like 16 legs on either side. I mean, it's the only chip like it that has a ton of slides. They tend to like to put yellow arrow, little paintballs on it too. You can buy this chip anywhere. I don't know the cost. I know people that have replaced them. I guess if you know it's getting power and all's good, maybe when you try to program it, it won't program. maybe maybe it's time to replace it. So far, what I've been checking on it is really the fact I just want to look at the legs that are soldered. I kind of check out the stuff around it to make sure it doesn't look fried. And also on the other side, there is a few things that might affect it. I mean, these two guys actually run power and communications down this way. So let me switch over to the microscope. I think. Let me see what I want to do. I did so well last night, and I was really bummed out that the that the audio didn't work. All right. So what we're going to do is we're going to hook this dude up, and we're going to read it. And we're going to switch back between the microscope, the camera, and the software that I'm going to show you, because you're going to get to the software and you're going to say, well, what do I set there? And so I want to start that. So we know the PIC chip is here. We know the line's here. Just one thing of note. James, I don't know if that was you that ran across that or Daniel. When you plug in this guy to your board, and I'm going to plug it in under the microscope actually, I could literally plug in on the back by the PIC chip, or I can plug in on the front where the power comes in and all this power stuff is. And what's really weird is on the T17 board, it won't work on this side, but it will work right next to the PIC chip. And I don't know why, but it makes a difference. And somebody else had that same problem. I said, flip your board over and do it next to your PIC chip, and it works. So keep in mind, you've got two ways to do this. If one way is not working, you might try the other way when you plug it in. Okay? So let's take a look at the software next. And so I'm going to capture my display. I'm going to turn off. Let's see, I can do this. And actually that does it. So I'm going to hide Streamlabs for a minute. Got to keep chat kind of going. So the software I got, I'm on a Mac, but you can get it, is from microchip.com. And so I can't see the chat, but I'll see it if you guys write it in a second. So it's from microchip.com. And when you download it, you basically get two programs. Now, when you're installing it, they'll say, hey, you haven't installed a compiler, because literally you could write like C code and throw it on this PIC chip and it would run whatever you did. But we don't know how to interface with the hardware, so you don't want to do that unless you're really brilliant. I don't have time to reverse engineer that one. Somebody's done it though. So they give you two programs. One is the IDE, that stands for Integrated Development Environment. That's for if you have the compiler and you're writing stuff. And then there's the Integrated Programming Environment, and this is actually what pushes code to the it pushes code to the board and reads the board. So I'm going to go ahead and start that guy up. Make sure I can see it. Hello, Armand. Thanks for joining me, guys. I was just going to do this recorded, but I kind of like the interaction if you guys have questions. So this guy's starting up. It's a Java application, so I haven't seen one of those for a while. So it's microchip.com. The software is free. It goes along with the Pickit. And we just wait. Or maybe it won't start because I don't have it installed. I don't have the Pickit, so it's going to do something now. It's actually kind of slow. I just had it running a few minutes ago, so I'm kind of not wondering, did it crash? It says it's running. Let me give it a second. I am encoding and live broadcasting video on a laptop, so I'm going to go ahead and hide this guy. Try to reduce some of the video. I'm going to move him over. I can't move him over. Ah, here it comes. It's just being slow. All right. So I'm going to, I can't see chat, but I'm going to start with this for a little bit, then I'm going to check back on chat. So this is the programming environment, okay? And there's a couple tricks you have to know to do this. And I don't even have this thing plugged in. So I'm going to plug it in, and that's going to solve one problem because it says select tool, and there's nothing there. So I'm going to go ahead and plug the USB part of my PIC chip, of my Pickit, into the system right now. and hopefully it'll show up. If it doesn't, I have to restart with it on. Okay, so the Pickit started. Let's see if it, yeah, so it recognized it. Do you see how that changed? So now it says Pickit 3. So that's the beginning. Now, we're getting ready to read this. I don't have it plugged in the board, so we got to plug it into the board. So I guess we'll do that now. So I'm going to take, like I said, it's going to be a little bit back and forth. It'll be a little clunky, but let me throw, let's do the microscope this time. And shut off that. And shut off. There we go. Okay. So hang on. I want to show you the connectors up close because there is something about them. You guys have done Pickit. Good. I'm going to flip this board over by the actual chip because we're going to come back to this. Let me get this to where I can use it and focus it. All right, so here's the PIC chip. And just to find your way around, let me straighten this out so I know which way I'm going. Sorry about that. All right, so let me get a pointer here. So this is your PIC chip. And if you're having problems, what I would do is actually just kind of go down and look at the solder joints and just make sure everything's good. Look at these capacitors, maybe test these capacitors, look at the resistors, just do an overall. Now this chip next to the PIC is the Eeprom. And so on the 17 series boards, the PIC chip is separate from the Eeprom. On L3 boards and some S9 boards, there is no Eeprom. And it is the PIC chip that stores the values for hashing, and you do have to flash it because the Eeprom, commonly, if you hook it up to a test fixture, does get overwritten and you have to reset it so the board will run under the Antminer software. Okay? So these are the two chips. If you notice, this says HT 813 or something like that, 02. So that on a hash code editor, this is what writes to that. The Pickit does not write to the Eeprom at all. In this case, only if you only have a PIC chip. And really, the only miners I've seen, maybe D3, but I'm not sure, but the L3 and probably the L3 Plus in those series and S9s only have this kind of chip, and it's probably different than this. So what I want to show you, though, is the plugs. And if you notice, one of these plugs is square, and all the rest of them are round. So you remember that mark, and I don't know if I can show this. It's going to be really big. Let me find it. So here's my cable. Remember that mark right there? So I was sure to plug in red wire there. So I know the red wire is where my mark is. And so when I plug this dude in, I want to put the red wire there, and you basically just slide it in here. It's really loose, but you just slide it in there. You might have to hold it so it stays connected. But my red wire went into the square peg. Okay? I'm going to pop out and, okay, no chat, that's fine. I'm just checking. I can probably put it over here and watch it. Okay. All right. So with that said, it's kind of hard to focus that when the wires come straight out. The other question we have is I'm going to go back to here, and we're going to look here. And so we've got this software. It recognized our Pickit. We have the Pickit powered up by the USB port, and it can talk to it. And we have the Pickit plugged into the card. But the question is what do we set here? There are tons of chips here. So I can it won't even list them, but it's so slow. But there's a family, and then there's a list of chips in the family. So the way you find that out is actually back to the microscope. Sorry, I got to move things around to get there. But back to the microscope. And let's have a look at that chip. So it looks kind of simple now, but if I tilt this dude, maybe I can get, there it comes in. So you go to the chip and find out what kind of chip it is. It should be labeled if you're lucky, okay? So this happens to be a PIC 33 EP16 GS202. And you know, I had that written down for my video last night, but I think I can find it. So the family is going to be, I think what it does is, let me see if I can point at this. The family is going to be PIC 33, 16, so it's going to be a 16-bit 33, and then the model is EP16GS202. So we've got to go find that in our software. So let me switch back to the software and bring that up and hide Streamlabs. Okay, so the first thing you want to do here is you want to go in and open up the families, and if you can find that, you remember that PIC 33? There it is right there. So this is the family of my chip. I'm going to choose that, and then it produces a list down here that I have to go through, and I think it was EP16GS202, something like that. So I mean, there's a ton of these guys. I'm just going to scroll down till I find an EP, a 33 EP, but these are the labels that are on the chip, so you need to match that up. Okay, we're in the EPs, but I need a 16. Here we go. So here's DS-PIC 33 EP16GS202. Okay? So I found my chip in here. I set the family. I've got the tool. It's cool. I'm going to hit apply. The reason I hit apply is it'll save it for me. Okay? So it's applied. Now, when you first open this out of the box, you will not see this menu on the left at all. And we'll get to that later. But since I've got everything plugged in, I should be able to connect, right? Not really, but I'm going to go ahead and connect because you'll probably do this. So I hit connect. And we wait. Okay, good. So basically I got an error, right? So it found the Pickit. It found the Pickit, it found the firmware, but then it gave me an error, target device not found, could not detect target voltage VDD. Okay, so you will probably have this error. This PIC chip is used to having power, and the power needs to be on to program it. Some PIC chips, I guess, supply their own power, kind of like Eeprom, but this one doesn't. So we have to go tell the MPLab, the programming environment, to power it on. Like I said, you'll do it here, but this wasn't there, so I want to show you how to get there. So I think you have to go to... So to get to this menu on the left, it won't be on there, and it's kind of weird. And I can't log out, so I can't show you. But you go into advanced mode, and once you click on advanced mode, it will give you a login prompt. And there's no password that comes with the software, but if you read the login prompt really closely, it says, hint, the password is microchip. So if you type in microchip, if you type in the word microchip, which is the company that makes this menu will appear, okay? And you need to get here because we have to set the power settings for the chip to be able to talk to it. So we're going to go do that right now. So we're going to go down to the power, and then here it is, voltage options, power target circuit from PIC. This is off, but you get to choose the voltage level. And I'm looking at these, and I actually went to the data sheet for the PIC chip, and I read the voltage levels that it could program under, and it's really versatile. It's like 1.4 all the way to 5.5. So in theory, all of these would work, but I know the PIC chip puts out 3.3, so I'll just like guess that. And you do need to check this checkbox on, okay? So those two settings have to happen for this PIC chip. On a different PIC chip, on a different miner, what I would do is try to connect. If you don't get this error, you're probably good. But I got the error, so I have to choose the power option. So you can go back to operate, and now you see I have a lot of options, okay? So I'm going to read this PIC. I'm going to read this PIC, and I can't display it. I think there was an option display. I couldn't find it, but I'm going to read it, and it'll print the output down here. So it found it this time. Telling me what memory address it's reading, and it says read complete. Unlike the Eeprom thing, it doesn't display it. Now it might display it. I mean, I might be able to go to memory or something, but basically what you do is you export this puppy. So I'm going to go up to File, I think it's File, and I'm going to go to Export, and I'm going to export the hex of it. And I'm going to save it. I'm going to say this is my bad one, okay, and I'm going to overwrite this. But Okay. So I'm going to overwrite the bad one. So it exports it and created it. Okay. So now, what I did yesterday was, this was the bad board. I went and got another board and I read it. And then I compared them. I'm going to show you how I do that. So I'm going to unplug the current board. You can't see it. I'm on video. And I've got another T17 board. The PICs should be like each other. I'm going to plug it in. Okay, it's plugged in. I'm going to disconnect and reconnect. I don't know if there's a reason to do that, but I will. So this is a different board now. Ooh. This board was fried, so maybe I don't have a PIC on here. Oh no, it's reading it. Let me disconnect. Let me try connecting again. If not, I'll choose another board. I've got a stack here. Yeah, okay, it's reading it. Nope, it doesn't like it. So let me choose another board that actually has a good PIC. One moment. Okay. Try this again. That fit tighter, so just let me try this for a sec. Okay, it seems to be happy with this. So I must have fried my PIC chip on that last one or lost it. That board got really hot and I blew out. When I was just learning, I blew out like 20 chips. So, all right. So this one's good. I'm going to read it. Let's just say this is the good one. I'm going to read this. Okay, it read it, and then I'm going to export it to a different file. I'm going to call it my good one. Okay, and I'll overwrite this dude. Okay, so I've got these two hex files, and the reason I did this last night is I really wanted to see if I needed to flash the PIC or not. Because if I pull it off the bad one and it's got garbage in it, it should not compare very well to the good one. So what I did, this is actually from when I did the video last night. This is a Unix shell. It's on a Mac. You can use command. I don't think Windows has this, but there is a command called diff. And this is the two files, bad hex and good hex. So you can run a diff. So these files look like this. So they're just lists of hex, okay? And you can play around with them. It's kind of interesting. I looked for BD, which was the good code, and there actually was BD in a bunch of places, so I don't know which one would it be returning out of memory that it was it. But let me quit out of this editor. I don't want to change them. But if I do a diff on here and there's any difference between the two files, it'll show up here. If it just returns to a prompt, it means they are identically the same. And these were identically the same. And my one last night with the error that I showed you at the beginning of this was identically the same. That's why I think it's not the flashing of the PIC that's the problem. It's either the PIC chip communicating or the board communicating. And that's kind of how I discern that, okay? That was the steps. All right. So let's just say it was bad, though. I'm going to close this guy. I'm gonna switch back to the bad board. So I'm gonna put the board I just read the latest stuff off of, and we're gonna go through reflashing it now. So I'm gonna reconnect the PIC chip to the one we started with tonight. Okay, and now what I'm gonna do, we could restart this, but I'm not gonna restart this. But what you want to do when you start it is actually import a hex file. So I'm going to import the hex file I saved, the good one. And so I know that's present. It said it's loaded. So I've got my board plugged in. I'm going to actually program it. It takes a lot longer than the Eeprom code editor, which is just a programmer. So it erases the device, which is set up. If you didn't want to erase the device, I think there's a way you can tell it not to. Whoa, look at that. Am I loose? Cool deal. Let me try that again. I'm holding the cable a little bit tighter now. Okay, so the cable is loose, because remember you kind of just drop it in there. It's not very tight. So I'm going to go ahead and verify it. I think it rereads it and compares it. Okay, it's all good. So good. So I successfully saved a good file from a working board, opened it back up, read it in, and programmed it and reflashed the PIC. For you guys with L3s and some S9s, you're going to be doing this because the test fixture probably blows away your Eeprom settings. I can imagine. I'm not positive of that, but it could be. So that's that. With the exception of the Pickit, this software is free. It's what I use. It's from microchip.com. And let me see, is there anything else I wanted to say tonight about that? Any questions, guys? You've all been here. Everyone know this already? I'll bring the chat back over. And I know there's a delay, so I'll get my mouse over there to get it. I'll wait just a sec if you have a question. Otherwise, that's going to be kind of it. It's probably stuff you already knew, but when I publish it, there are people that don't know this. So, and that was a purpose. I just decided to do it live for folks to ask questions. Okay. Hopefully my delay isn't so much that you're probably just getting my question of is there any questions. I appreciate logging in tonight. The next time I do a live broadcast, we're back to replacing chips. I think I have one to replace, and I'll get there. I just wanted to get this video out of the way and done. So I appreciate you guys logging in and letting me know there was no audio. I really appreciate that. I'll go trim that guy down for folks and fix that. So thank you guys. Thank you for being on Discord. I'm glad you are. And those guys who joined from YouTube just because I was live, please subscribe. It helps me out, okay? Or that bell notification. Yep, thank you. Thanabun, thank you. If I pronounced your name right, I hope I did. So have a good evening, you guys. I really appreciate you tuning in.